Good day, everyone, and welcome. My name is Kayla Altman, and I am a Communities Coordinator here at ASUG, and I am pleased to welcome you to our second installment of the Internet of Things webcast series, Transform Business Operations and Reimagine Business, and thank you for your participation today. Today's webcast is being recorded. The recording and the slides will be posted to the ASUG website later on today, and all registrants will receive an email with the link to these materials. If you would like to submit a question during the presentation to our speaker, you can do so by clicking the Q&A panel, which is located in the lower toolbar of your screen. Simply click the box that says Q&A, type your question into that interface, and we will be able to moderate those questions once the presentation has concluded. Lastly, we do have a few poll questions for you at the conclusion of the presentation, and we ask for your feedback in addressing those questions to help us better understand what you'd like to see in the future. Before we officially begin, I do have a few additional announcements to make. The first is a reminder for any of you on the line today who are Business Objects users that the 2015 SAP Analytics and Business Objects Conference will be hosted in Austin, Texas, August 31st through September 2nd. Registration is now open, and we do invite you to attend. Co-located with that event will be the annual ASUG SAP Business One Summit. So if you or any of your colleagues or contacts are Business One users, please encourage them to register via asug.com and join you in Austin. It is now with great pleasure that I turn you over to Paul Kurchina, who is ASUG's Community Advocate for Internet of Things, and he's going to officially kick us off today. Paul?
Thank you, Kayla, and welcome everyone. So before we get off into more a virtual presentation, I want to highlight an upcoming face-to-face event. June 23rd to 25th of the SAP Manufacturing Industries Forum. Various SAP industries are participating. This will be a great customer event, and really why I want to punctuate it as well is there's a fair bit of Internet of Things content embedded in that event, starting with the Internet of Things workshop on the 23rd, and we have one of SAP's global co-lead, Michael Lynch, who actually spoke on a webcast last week, is also a presenter at that event. And I'll be participating in this event as well to engage with attendees, talk to them about what they want to hear about in future ASUG IoT activities, and hear some more of their stories. Next slide. Just before I introduce, turn it over to Demet Lair, deliver today's presentation, just want to highlight again, this is episode 2 of our 8-episode webcast series. We run from now until July 9th with the whole series of webcasts from SAP, the German user group, as well as SAP partners. Really helping you understand in terms of where IoT is at today and really the possibilities to make a difference in your business. I want to highlight especially next week's webcast on June 9th at 12 Eastern. We have David Parker speaking about from big data to smart data. So that'll be a whole conversation around Internet of Things and big data. So I hope you can join us on that webcast. So without further ado, actually just before I turn it over, just a reminder, Kayla mentioned the polling questions. At the end of the sessions, you'll be asked 3 questions. And I really appreciate it if you can respond to them and really give us your input. One question will be, what is it one key thing you got out of today's presentation? Second question will be, what may you be missing? What things may you want to further understand better? And the third question is what are other future topics you would like to learn from ASUG's IoT community? We're going to have a whole series of content around IoT planned shortly for the balance of the year. We're already planning now a pre-conference workshop and other activities engaged with TechEd. So your input would be most appreciated. So without further ado, Demet, I'd like to turn it over to you.
All right. Thank you very much, Paul, for the introduction and the opportunity to speak today. My name is Demet Lair. I'm a Vice President and Chief Technical Advisor at SAP, and I'm part of the CTO team. And our role is to basically evangelize the technology at SAP, but more importantly, maybe to discuss with our customers and be the voice of the customers when we basically do product strategy and planning with engineering. So something that is very important in a space like the Internet of Things and big data. We at SAP are working on a number of new products and initiatives, and so we are the voice of the customer in that strategy project and planning. So last week, Michael Lynch gave us a great introduction to the IoT and the space and what that means for businesses. And in this webinar today, we wanted to talk about something a little more specific on the technical side, really look at more of the technical implications of IoT on our processes. So I'm going to start with a very few slides, just a couple of slides on again, why is IoT important, what it is, but then I will dive straight into the topic of this presentation. So these are the usual numbers, right? Michael had a lot of these numbers as well. You know, basically the main thing to get out of this is that the Internet of Things emergence is something that is not going to stop, something that is accelerating. I know that last year we were saying with the numbers for the number of connected devices by 2020 was 25 million, then it shot up to 50 billion, and now we're looking at 75 billion. And I'm sure, you know, by the time we get to 2020, we might find out that it's even more than that. So, you know, the bottom line here is that we are deploying a lot of devices. These devices are becoming more and more aware of the environment and are connected all the time. So basically, we are entering an era of hyper-connectivity. This is the main thing, and this is going to transform our lives, but also the way we do business. Something that, as a person with a technology background, I find interesting, maybe even more interesting than the number of devices, is the way the Internet is evolving with the devices. If you look at it, the Internet studied as a machine to people architecture. We are basically putting content of great value into some of these web servers and then pushing down to a large number of people. And this is how we basically architecture the web. And the web was a technology that is scaling really, really well through web servers and caching technologies, content distribution networks and the like. So over the years, since the Internet exists, we've learned how to scale that Internet very well. And then, a few years ago, the trend of social media, Facebooks and microblogging like Twitter has kind of changed a little bit the balance. Now, each and every of us can become a contributor to the web. So, the balance has changed a little bit, but overall the architecture remains the same. Now the Internet of Things is going to radically change this because basically now we've got all these devices that are going to be connecting to the web, and they all have something to say, but what they have to say is not necessarily of great interest. It could just be a change in temperature somewhere. This is not something that thousands or millions of people will care about. So this is something to keep in mind. It's not just that we have more devices being connected to the Internet, it's that the Internet is evolving. The nature itself of the Internet is changing from something that was designed a few years ago to move content of great value from central locations to many people. So now we've got the very peer-to-peer, machine-to-machine Internet emerging out of this. And we'll get back to the implications on the technology side. Now at SAP, when we talk about Internet of Things, I've got to say a lot of our customers are still wondering whether this is relevant to them, because when we read about the Internet of Things, a lot of time in the press, we tend to hear about all the big names, about all the trendy and flashy technology, things like the Nest thermostat or the Apple Watch or Fitbit. Right, and a lot of people are looking at us and saying, okay, I'm in the manufacturing business, or I'm in retail. Why do I care about all these things? And the fact is, devices nowadays doesn't just need consumer devices. A lot of the things we deploy in our corporate environments now also have the ability to connect and give us information. So here, for instance, we've got things like air compressors, ball bearings, tires. When somebody told me that ball bearings now were had the ability to send information, I was a little skeptical and surprised. This is probably not something that we expect to be part of the Internet of Things. But the fact is, everything that is of value that we deploy within an enterprise now has the ability to connect and report back to somebody, and maybe also to be acted upon. So the Internet of Things is impacting each and every of us, no matter what industry and line of business we might be in. This ranges from, the supply chains, asset management, connected retails, of course, things like smart cities, connected healthcare. There's a lot of very interesting things happening on the healthcare side. Connected home and connected cars. I think these are things that we're quite familiar because there's a lot of things being written about these domains. But bottom line, the Internet of Things is not just on the consumer side. It's happening and it's relevant to all line of businesses. So why should you care? So first of all, as I said, it's everywhere. But the other thing is that there are a lot of estimates around, inflated estimates around the number of devices being connected. But now there's also some very interesting studies happening on the business implications of the Internet of Things. And so there are some interesting numbers like this one, 14.4 trillion increased revenues and inefficiency gains that could be derived from the Internet of Things. The other one that I thought was released just last week, I believe, by IDC, was quite interesting, talking about 19% increase in the IoT revenues in 2015. Actually, a lot of that was through on the ad side, but basically the business implications of IoT are now also clearly emerging, and so there is basically a lot of value to be derived by each of us in that space. And maybe just the last line on this topic, pretty much. Whether you're dealing with factories, the Internet of Things will help you run these factories better. This is what we call smart factories. Whether you have logistics problems to deal with, you'll be able to run this better through connected logistics, being able to know where is what, where each of the resources are at any given moment, basically. And then a lot of innovation to be done on the customer service side, through predictive maintenance, through a better informed customer service, and the likes. This is actually a tweet that Aaron Levy, the CEO of Box, sent recently. I think it was just last month. But I think this is interesting and good transition into my next slide, which is, in enterprise software, our focus has always been about making work more efficient. And for the first time in a long time, probably, the technology, and that is the hyperconnectivity and Internet of Things, is basically enabling us to potentially reinvent the way we do the work. And let me elaborate a little bit onto this before we go into some more technical details. But this is what we call a maturity model for Internet of Things, and I believe that Michael Lynch also talked about this last week. So just a quick recap on that. But there are various phases to how we're going to be embracing Internet of Things and leveraging its benefits. Here, we're going from this is our maturity model, and on the y-axis here you see the potential benefits. But basically, we're going to go from this ability to benefits to gain all over the place. Whether you're simply connecting your devices, there's a lot of benefits from being able to connect all these assets that we have within the enterprise. And Because basically once we have connected these assets, then we can start transforming the way we do business. We can optimize things that were mostly driven by people before. By having better information flowing through our systems, we can be more efficient. So, these are the phases. Connect your devices, transform and optimize your processes. And again, this is the typical thing of enterprise software. We're being better at what we do. But what's interesting about the Internet of Things is that we have an opportunity to reimagine the way we do business. And we'll have more examples of that, but I'm sure you've heard about this. Uber is a great example of how people have been reimagining business. This is not about doing something that we used to do before. It's about taking what we have, taking some of the new technologies we have, and basically reinventing the way people do transportations. All right, so this is a short introduction to the Internet of Things. Again, if you need more information on the business benefits and the like, I would really refer you to the replay from Michael's presentation, the first webinar in this series. Here I wanted to start talking a little bit about the web consensus on the technical side. Also, remind everybody that the Internet of Things is not just these shiny devices. It's really everywhere. And I wanted to start with something that a tweet from Bill Gates last year, I believe, was about the cement business. So something that is probably, you would think, is light years away from the Internet of Things, right? We're talking about construction and pouring concrete. But actually, the cement business is something that is extremely active right now in China. Over the past 3 years in China, they've poured more concrete than we have in the US in 100 years. So this is something that is a huge part of our society today. And there is tons of improvement that can be made in this. The cement business is something that was started years and years ago, decades ago. And the way we do things today is still pretty much the same. We still have the same machines. We're still using machines that were maybe built in the 60s and 70s. As you can imagine, these are far away from a Nest thermostats. They're not IT-enabled or the likes. The processes are all siloed. When you change something on one, for instance, on the kiln or something on the conveyor belt, there is no correlation or no ability to figure out what the impact on the complete chain. Yet the cement production is something that is one very interesting specificity of the cement business is that it has to be done just in time. There is no way to store concrete that is ready to be poured. Once you've prepared the concrete, it has to be delivered in less than 45 minutes. So this is something where a lot of optimization could be done. And this is a good example of how something like the Internet of Things can be applied to some very traditional industries. Because basically, if you have the ability to have instrumentation in each and every step of this chain here, be able to bring all this together and understand the impact of each and every change along the way, there's a lot of optimization that's possible. And we have customers today working on some of these problems. So all the way from crushing the rocks all the way to optimizing the routes of the trucks delivering the concrete. So the key message again is don't think that because you're working with something that is very traditional, you cannot benefit from the Internet of Things. The Internet of Things and the things it enables can be applied everywhere. Another example that is that we can look at is tires. I was talking about tires a bit earlier. A lot of the new cars today come with sensors on the gauges of the tires. So basically, you can look at your dashboard and see what is the tire pressure. Typically, you get an indication if something is wrong. But this is an interesting thing. We have a lot of sensors everywhere in our life today, but these tend to report things in a very isolated fashion. So basically, right now, you're going to get maybe a red alert on your dashboard. Now, what would be much more interesting is that if you were able to look at the history of these things. So for instance, instead of just seeing when a tire is deflated, if you could see the trend that it was actually been leaking air for the past 3 weeks. If we had been able to detect that, first of all, we would have been able to do things before it's too late. So there is a lot to gain simply by being able to look at things over time. That's the first one. But in order to do this, we need computational logic, which typically you do not have in your car, or not too much. The other thing is, if you were able to look at these things in context, not just at one tire, but let's say start with the 4 tires on your car, you could see that one tire is not behaving like the others, even though they're all in the same car, mounted on the same car, so they're all subject to the same temperatures and light. So if we're able to look at the context, we will also be able to derive more value. And the context can just be your car to start with, but it can also be all the cars around you as well in that region, all subject to some weather variations and the likes. So context is very important. History and context, and computational logic. And a lot of that today is not possible simply because these sensors are reporting locally. So that's, again, another thing behind the Internet of Things, that simply by connecting all these sensors and collecting this information across a lot of different devices, across a lot of different regions, we can derive much more value than we're currently getting from these sensors in an individual fashion. So what are the problems that we're going to be facing as we try to basically do this type of things, which is go from the display of one tire pressure on one dashboard to actually looking at this in the context of millions of vehicles on the road today? There's a number of challenges and the thing we need to start looking at is the way we've been building our systems within the enterprises. We've got two very distinct technologies. Operational technologies were from the bottom actually delivered by the equipment manufacturer. Those we used to build machines now converting software to give you a better service on these machines. We're talking about displays and the like. But the software typically is still maintained by the people operating the machines. Their core, their real manufacturing. We also have information technology. This is basically software that was built to flowing through our enterprises. Talking about the customer records, track RMs. We're talking about managing inventory records. All these systems were built, typically sold by software vendors, and typically built on IP technology. So these two domains of technology and information technologies are still typically in most cases very distinct and very different teams. Now, in order to realize the value of the Internet of Things, we need to be able to start breaking these walls. And this is becoming increasingly possible today. First of all, because the equipment manufacturers are embracing things like IP or network protocols, but also because we have a lot of other vendors like, for instance, OSI Soft and the likes, who now, even if the machine itself is an old machine, so we're talking about this kiln in the cement factory before, even if these machines were built in the 60s, by deploying some technology in between, we're actually able to extract information and interconnect this with other systems over IP networks. So there is now the opportunity to bring these two domains together and to realize some of the benefits of the Internet of Things. So that's the first thing. We need to be able to break that wall between operation technology and information technologies. The other one is we need to look at our processes. A lot of the processes that we have today in enterprises were basically designed for people. And as a result, they are typically batch-oriented. If you look at something like inventory management, warehouse management, you've got people typically walking around with, initially with clipboards, after that maybe with tablets, could be barcode scanners, but typically people are collecting information, then going back to their workstations and finalizing the work. So there is a lot of, it's mostly batch-oriented. But at the same time, now warehouses are evolving, right? A good example is the Amazon warehouses. Everything is operated by robots. Each and every piece of inventory is typically tracked through RFIDs or other technologies. So we have very, very granular information about our inventories, and all this is done in real time in straight-through processing. So basically, we need to reinvent our processes, and we need to have the system to support that reinvention, going from batch processes to real-time processes. That's the number 2 things. The other thing to keep in mind is as we start doing this, we are going to be facing a lot of data. A good example of what is coming our way is what happened in the utility space with when they started deploying smart meters. Basically, before that, a typical electric meter would be looked at once a month by somebody walking from house to house and reporting back to the data center. And now these smart meters are reporting once every 15 minutes. That resulted in an increase in 3,000 folds of the data that was going back to the data centers. Now, this might not seem like a lot, but it's actually huge. And this is actually one of the reasons that while we talked a lot about smart meters a few years ago, and a lot of us nowadays have smart meters deployed in our homes, we have seen very little as consumers, very little changes in how we interact with our utilities company. And one reason of that is, again, the smart meters have been deployed, but realizing the value of the smart meters is incredibly difficult because of the amount of data that companies have to deal with, and because many of them were not ready for that. So this is another thing to keep in mind. It's not just about connecting the devices. We need to make sure that we have the processes and the backend systems that will be able to handle the extra lot of data and do something useful with it. And talking about data, that means that we need to have a big data strategy, right? So looking at the smart meter problem again, typically when we have these mechanical meters, basically we're talking about a small utility with maybe a few million customers was probably storing about 100 gigabytes a year. And people on the line or in the utility space can probably correct me here, but we're talking in the order of 100 gigabytes. Now with smart meters, we're talking about something more like 12 or 15 terabytes. So, and this is for a small utility company. So you can no longer put this type of data into a traditional relational database. You need to seriously think about new technologies, big data, probably Hadoop and HDFS. The other thing about all the data coming from these devices is that in the case of smart meters, we're probably talking about semi-structured data, but if you're looking at other type of sensors like cameras, we're talking about a lot of unstructured data coming to us as well, photos and the likes. So we need to also look at how we're going to be storing this information coming from the sensors. So a big data strategy is going to be the cornerstone of any Internet of Things strategy. Next in line is the ability to basically look at the data as it comes in. So we said earlier that we need to move from batch processes to real time. And for that, we need to have the ability to, first of all, cleanse the data and filter out all the noise. We're going to be getting a lot of data that is useless. But then we need to be able to detect trends and patterns. So in the case of a smart meter, it's pretty simple to elaborate, but it could be something like a leak, right? So how do we detect that something is leaking or something is not usual? We need the technology to be able to do this in real time. And for that, there's a number of technologies that can be used. Complex event processing is, I think, a very important technology that would need to be considered for the Internet of Things project. Now, being able to detect things in real time is interesting. It's needed for the Internet of Things, but what is even higher value is being able to predict where things are going. Being able to predict that something is going to fail, being able to predict that something is not is going to behave in such way or another. And for that, it means that we need to be able to deploy predictive technologies. And there's a lot of very interesting tools that can be used today in the machine learning space to this type of predictive detection. So real-time complex event processing and predictive capabilities would be next in order to realize a lot of the value of the Internet of Things. And once we have this, basically these basic building blocks, which is, again, we talked about bridging the gap between both operation technologies and information technologies, moving from batch processes to real time, having the capacity to absorb this tsunami of data, being able to store it in a big data store, being able to detect patterns in real time. The next thing that we need to do is be able to build new processes to basically handle this, right? So now that we have the capability to detect certain patterns, what do we do with it? So we need to build new applications, new logic, new ways to interact with our customers. And there is nothing easier there than the cloud. The cloud is a lot of great value because it enables us to try things very quickly. We can bring up a new environment very quickly, try something. If it fails, dismantle it and move on. So we can do a lot of experimenting with the cloud approach. And the other thing is, once we found the right approach, we can scale very, very rapidly. So again, that is key to be able to handle all this data and to move rapidly. The cloud will allow us to iterate, try to find the right way to deal with this new information that we have, and then scale fast. One of the last considerations here that I wanted to bring in, this is maybe raising more questions than giving you answers here, but I think it's an interesting consideration because we are talking earlier about the way the internet has been changing, evolving over the years. We moved from this World Wide Web, where we're moving high-value documents from web servers to people. And we built a complete ecosystem around this. We've got a lot of vendors, for instance, specialized in internet caches, and vendors specialized in content delivery networks. And these have scaled really, really well. You know, we moved from these very static web sites to e-commerce sites. All these have been working very, very well. Again, what's coming at us with Internet of Things is something radically different. As I mentioned earlier, now we've got all these sensors connected to the internet, and they all have something to send back to our data center. But typically, it's not information we want to cache, right? So this is information maybe coming from, again, going back to that tire example. You know, the pressure of your tire needs to come back to the data center of the tire manufacturer, maybe, but nobody else cares about this but you. So implementing things like caching strategy in this type of environment is going to be very, very interesting and challenging. What does that even mean to cache, right? So basically what I'm saying is that we are literally turning the internet on its head because we're moving from this internet, this World Wide Web, where we have this high-value content being pushed to many people, to this very chatty internet with a lot of devices and people who have to say very small things, and they're all pushing this back to the data centers. And along the way, we have a lot of questions as well, which is, what is identity? It's very easy to understand that a person is associated with an identity on the web. Now we're talking about sensors and devices. You know, the camera that you have in your backyard, temperature sensor in your laundry. What does identity mean? and yet there's a lot of privacy and security challenges around this. Actually one of the biggest impediments that is predicted to stand in the way of the Internet of Things is security and privacy. So there's a lot of things that need to be done there. A lot of the technologies we invented for the web will probably not be applicable. Some of that might be reusable, but a lot of it needs to be reinvented. So again, just because it's called the Internet of Things, I think we should be careful not to assume that what we have deployed in our data centers is going to be applicable to this new world. A lot of questions still remains as to how we're going to be able to scale, connect, secure, all these things. And this is why I think more importantly than ever before, partnerships are going to be very, very important. Before, up to now, you were going to a vendor like SAP to get maybe your enterprise systems, right, to get your ERP and now databases and the likes as well. But now as you deploy Internet of Things strategy, you're going to be looking at everything all the way down to a very dumb device, potentially. We're not even talking about mobile phones and laptops. We're talking about very small memory footprint, low computing capabilities devices that will need to be connected. And it's not necessarily just IP networks. It could be anything, radio, or it could be Zigbee, whatever, all the way up to a very elaborated enterprise system such as maybe contextual marketing. So there is no way you'll be able to get all this in one package from a single vendor. And this is why partnerships are going to be key and critical in this brave new world of the Internet of Things. The other thing that we will need is APIs. A lot of the systems we deal with today are typically accessed by people, and so we deal a lot with user interfaces. But now these devices are going to need to talk to each other, and APIs will be also seeing a lot of demand moving forward, because that's how you're going to be able to get all these vendors to talk to each other. And this is why standards will be very, very convenient. But at this very moment, mid-2015, the fact is that we probably have a lot of confusion in that space. We still do not have any real mature standards when it comes to Internet of Things. We see some interesting alliances emerging. For instance, the Industrial Internet Consortium, or the OSIN Alliance, that was started by Qualcomm and the Linux Foundation. So some of these consortiums are trying to define reference architectures and basically give us the framework to build these systems and enable the ecosystems that we just talked about. Of course, you also have the standard war going on between Google and Apple, the Weave versus HomeKit. And then new entrants like Huawei, which just announced an Internet of Things OS, for instance. So on the standard side, the key message is that there's a lot of things happening. There's no clear winner yet. So we need to be ready to switch things. And that is probably one of the difficulties of the Internet of Things, that whatever we do today, we need to be ready to change fairly quickly, because things are still moving at a pretty fast clip. So what are we doing at SAP in order to make it easier for you to deploy this Internet strategy? So on our side, we're really trying to take an approach that is driven by business. How can we change the way we do business and deliver business value to the Internet of Things? And this spans everywhere from R&D to aftermarket service. The key to tie all this together is really the smart data. And if you look at it today, there is no data flowing all the way from R&D to aftermarket service. All of these typically operate in silos. And what we need to do with the Internet of Things is start bringing all these things together to derive extra value. To do things like connected manufacturing, energy management, predictive quality, Predictive maintenance, I think, is one that's getting a lot of traction now, and probably because it has a lot of very immediate value. It's also very easy to understand that if the manufacturer of some of the machines using today, some of the objects using today had direct access to these machines, they could actually predict faults and issues ahead of time and give you a much better service. So instead of calling the manufacturer when your dishwasher goes down and breaks down, you can actually get an email at some point telling you, you know what, your dishwasher has been heating up quite a bit. There's probably some fault in the heating component of the dishwasher. We offer you to dispatch somebody to your house next week. So basically now, instead of being in a reactive mode, the manufacturers can actually help you solve the problems before they even occur. So predictive maintenance is one of the most interesting and rapidly adopted scenarios in Internet of Things. But also, supply chain, connected logistics, R&D, and sales. So there's value to be derived everywhere. And so at SAP, we look at this through delivering new products, working on process innovation, and business model innovation. And let me go into more details in a few slides. So the first thing is intelligent assets. So let's just be clear here. At SAP, we build software. We do not build hardware. So this is not something that you're going to get from us. You're not going to get a device from us. You're not going to get the network either from us, right? So typically, these are things that you already have within your company, or you're going to buy from a hardware manufacturer. On the other hand, what you can get from us is a device management platform, something that will let you move the data from one cycle to another, from one department to another. We also can deliver you the platform to build applications on top of that for Internet of Things. And then we can also package all this and actually deliver end-to-end industry solutions. And I've got a list of the solutions that we've already built for the Internet of Things. On the other end, when it comes to these lower layers, we've assembled already a very comprehensive ecosystem of partners. I think one of the strengths of SAP in this Internet of Things is that we are known to be working very well with partners. We have a long legacy and history of working well with other vendors. Not everybody can do this. I think a lot of technology companies will find it hard to actually be an actor in the Internet of Things space simply because they didn't know how to partner. But we have a long tradition of doing this, and so we've assembled on the device side and on the connectivity side, we've already assembled a very comprehensive and very efficient partner network. For instance, on the connectivity side, we were partnering with Jasper, but we also at Sapphire recently we announced the Siemens and platform industry, which I think is very interesting. This is Siemens is building this heavy manufacturing equipment, and when you get a machine from Siemens moving forward, that machine will have the ability to connect to their industry cloud. And when it's connected on the industry cloud, then you've got a very easy way to build solutions on top of that, talking about things like predictive maintenance, for instance. And same thing on the telco side. Telco networking is a very difficult space, something that, for instance, utilities have tried to do. Some utilities have tried to actually manage their own networks connected to smart meters. And some of them have made the wrong choices. They picked on the wrong networking standards. That's something that's really hard to do. And typically, companies are not experts at networking. So it's a good idea oftentimes to leverage expertise of telcos, for instance, in that space. And telcos now engaging in looking at the Internet of Things, not just your mobile phones anymore, but how to connect all the devices. So we have got partnerships with companies like IoT Systems and Ericsson in that space and more. To give some names to these platforms, as mentioned earlier. So when it comes to managing your devices, the offering from SAP is the HANA Cloud Platform for IoT services. So this is a platform that's available on the HANA Cloud. And basically a service that you can sign for as a subscription service. On the application enablement platform, which is how you're going to be building the applications, we've got the platform, the HANA Cloud platform, where you can build your own custom applications with all types of different front ends and logic. And then you've got the HANA Cloud integration, which is how you're going to be connecting these applications and all these devices to your backend systems, let's say your CRM or your ERP. The HANA Cloud integration provides a lot of these templates to interconnect all the different systems. And then on the industry solution side, we'll talk about the specific IoT solutions we have. But one thing that I think is very important, and we probably don't talk enough about, is the importance of S/4HANA in this. So S/4HANA is really the reinvention of ERP. First reinvention of ERP in decades, and it's built on real time. It's built in memory based on the HANA database. It has new front ends. And when you look at S/4HANA, it basically presents a lot of the characteristics and solves a lot of the problems that we discussed earlier. You know, it allows you to move from batch processes to real time. It allows you to scale, because remember, we used to have a few people talking to ERP, keying a few data in ERP, and now we've got all these tracking devices all over the enterprises, and they're all talking back to ERP in real time all the time. So the core systems of the enterprise is your ERP, and the ERP needs to scale in order for the IoT to strive. So to me, S/4HANA solves a lot of problems that people are facing on the ERP side right now, but it will also provide the platform that people will need in order to scale to the Internet of Things. So that's probably actually a very interesting topic for some future webinar, but to talk about the importance of S/4HANA as the ERP of things and how it's going to enable your core systems to scale to handle things and not just people anymore. I was talking about the HANA Cloud platform and the IoT service earlier. This slide gives us a few more details. I'm going to go a bit quickly so we have a little more time for the Q&A. But basically everything you'll need in order to build these applications is included in that service. So you can sign for this and you will get everything from the streaming capabilities. So we talked earlier about the need for complex and processing that is there. You have a need for storage in real time. It's there with HANA and Hadoop. You need the logic to build new applications. It's there, and you need the ability to integrate back into your systems, and it's there with the HANA Cloud integration. So that this HANA Cloud platform, IoT Service, gives you a rapid way to deploy these new IoT services. Again, at SAP, we're looking at IoT as more than just a technical exercise. It's really how to derive new value from what you have. And so I'm going to skip this a bit quickly, but again, we're looking more than just building blocks and technology. We're looking at how can we help you increase sales, increase uptime. We talked about predictive maintenance, increase customer loyalty. There's a lot of very interesting projects that can be done around contextual marketing, precision marketing, basically better targeting your customer base by leveraging the devices that they have and the information you can derive from that. Reducing costs, obviously. If we can string all these systems that we have, if we can better leverage information we're getting from them, we can be much better and improve our production processes. So, before I go into summary, I was talking about we've got the building blocks that you need, but we also have solutions, complete end-to-end solutions. And I was talking about that a bit earlier, but we've got things like connected manufacturing. I know that Michael Lynch talked about this last week, how we can basically be better at manufacturing what we do, enable things like a very custom production, There was this example about Harley-Davidson, where you can basically go on their website and basically build your own custom bike and get it made very quickly, versus before any custom order would take months and months to get delivered. Predictive maintenance is a solution that's gaining a lot of traction, again, because that's a very obvious one. Just by knowing, having constant information about your devices and the machines that you're selling, you know when what is going to fail, what will need a replacement, when you need to send new supplies. So there's a lot of extra services that can be added onto this. Connected logistics to better enable your resources, your constraints, and basically allow the flow of goods. Things like augmented reality. So these solutions are end-to-end, and we've got a long roadmap of more solutions. But if we recap a little bit about what we talked today, again, it's more of a more technical approach to Internet of Things. In order for us to be able to realize the value of an Internet of Things, we need to look at how we're going to be able to converge these two typically distinct domains of information technology or operational technology. So that's something that we'll encourage you to start looking at, depending on what side of the fence you're in. I suspect many of you on the IT side. Start to engage with your colleagues on the operational technology side and think about what type of standards they have, what type of technologies they have, and how we can maybe start connecting some of these. Security will be a very difficult one, how we basically have senior security across these two domains, but that is needed, right? It's not just going to be about connecting things, but we need to be able to scale all the way to the core. And the core in that case is probably your ERP. So think about things like S/4HANA, right? Because again, if your ERP is still R3 or R2 and you're struggling to scale with simply the users you have today, which are just your employees, think about the challenge you're going to face when all the devices in your machines will want to send some information that eventually will end up in your ERP. And that's this is actually part of the same, more or less part of the same problem, which is we need to move from batches to real time, and even more importantly, predictive technologies. So machine learning to me is probably going to be one of the most interesting and one of the most challenging things moving forward. Actually, I was just reading an article the other day about how Gartner is predicting that there will be a marketplace for things like algorithms. Basically, how do we improve things through algorithms? And there will be so much IP and so much value to be derived from that we're going to see some real numbers associated with algorithms that people will be able to deliver. So I would, in data scientists, machine learning people are really hard to find. They are scarce resources. They are typically expensive. So I would also encourage you to start looking into hiring some of these people today, because they are going to be key to enable value, to deliver value on top of the Internet of Things. This one is pretty obvious, but if we have a lot of devices all sending data, we'll need some very serious big data capabilities. So if you don't have a big data strategy yet, and if you're thinking about IoT, you should definitely look at big data first. The cloud will be very important, again, to be able to iterate and fail fast, but also scale eventually. Ecosystem of partners is required. It's probably now is a good time to assess the competency of your different partners, everything from hardware vendors to software vendors, but also system integrators when it comes to IoT. And on the standard side, I would say don't expect too much yet. They are emerging, but I suspect that you will want to deploy something before the standards are set in stone. So be ready to switch and maybe pick different ones in a few years down the line. So at SAP, we've assembled a stack, we've assembled partners, we've got a lot of building blocks, but we also remember we've built our ERP in order to deliver the platform for the business of the future and the Internet of Things. Now, these are all technical stuff, and it's all good and well, but at the end of the day, nothing is more important than we can deliver we can improve our processes with all these building blocks I mentioned earlier. But remember, the value of IoT will be delivered when we can actually reimagine business. And that is going to be probably the most challenging thing to do, because now we need to somehow work with our business counterparts, bring them around the table, and figure out how we can leverage these new technology capabilities to reinvent business. And that is going to be really, really hard. One thing we do at SAP to enable this type of things is we actually use design thinking. I'm sure many of you have been involved in design thinking sessions before, but this is, I think, going to be key in the Internet of Things, in order to be able to bring everybody around the table and figure out, okay, now that we know exactly how our customers are using our equipment, our machines, how can we reinvent our business? So design thinking will be the cornerstone of this process, basically move away from a simple technology discussion to business reinvention. So with this, I wanted to thank you for your time. Here's my information if you want to reach me. And I think we've got a few minutes, not so many, but a few minutes for questions.
Thanks, Devin. Can you hear me?
Yes, I can.
A few questions came in. First one, thanks again. Do you think that connected objects is not more appropriate term than IoT? In fact, IoT is a confusing term, and most objects called IoT are not actually connected.
There's a lot of terms being floated out there. A lot of people, I think, are concerned about IoT being a bit vague. So people have started talking about maybe we need to actually divide the Internet of Things in multiple domains, and people are talking about industrial Internet, for instance. There's also M2M underneath this. There's also people have said that it's not an Internet of Things, it's actually more subnet of things. So, I've got to say I don't have a strong opinion on this. I think you're right. I think we could find a lot better terms. But the fact is, Internet of Things is still, I think, a convenient way to relate to a movement, to new things, new capabilities are being enabled by this hyperconnectivity. Typically, also, more and more often, I find myself talking about hyperconnectivity more than the Internet of Things. So yeah, I think we need to also pick the best term for industries. I think that the terminology will differ by industry. But yes, I agree. Internet of Things is a little bit vague and probably needs more refinement.
Okay, another question here.
One other thing is, I think that in a few years we'll not even be talking about Internet of Things, because in a few years everything will be connected, and it's not like there won't even be any confusion about this. It's just the way we will be doing business. So I think Internet of Things right now is a convenient umbrella, but also a temporary one. Eventually we'll need to find better terms and more targeted terms to define what we're talking about.
Great. How about this one? Some of your examples relate to very mature industries, probably relying on equipment from the 70s, if not earlier. And these are not going to be replaced anytime soon. How can companies bring these into the modern world of IoT?
Yeah, so that's an interesting one, probably relating to that cement business, for instance, right? So right now, when people again think about Internet of Things, they think about these new gadgets and devices that are IP enabled. But even if you're dealing with something like, let me talk about one of these, again, cement business, right? And you've got one of these rotary kilns, basically this high temperature ovens. And, there's probably no sensors on these, no IP-enabled sensors, right? But on the other hand, I'm sure that you can get information such as rotation speed. You can get things like temperature. And maybe these are not being sent over IP, but using technologies such, again, some partner technologies like maybe OSI Soft, right, and Paya Historian, which are typically already deployed there. This information is probably actually already being collected in some databases. And once it's in the database, we can actually have access to it and then publish it. So even though the equipment itself might not be connected, the fact that we have access to some of the information about how it is working right now maybe stored in some database platforms. That's enough for us to realize some of these IoT scenarios. And so basically, IoT scenarios and business value can be realized even though the devices we're talking about may not be connected directly to the internet themselves.
Thanks. Unfortunately, we're just about out of time. Kayla, could you put up the survey questions for attendees? For those people that are still in the line, I'd really appreciate it if you could take some time to think about what is your one key takeaway you received from today's talk. What are you still looking for some clarification on? And what are the really future topics that you want us to cover? We're already planning future webcasts on the subject of IT and OT with analysts and customers to further bring examples out to you. And that note, Demed, thank you for taking the time to present to us today. And Kayla, I'll leave it to you to close off.
Awesome. Thank you so very much, Paul. On behalf of ASUG and the Internet of Things community, I would like to thank our speaker for today for sharing this fantastic presentation, as well as those of you who joined us to listen. As mentioned previously, the slide deck and the recording will be emailed out to you later on this afternoon, and we'll also post that information on asug.com. Thank you again. We do look forward to next time. Have a great rest of the day.
Thank you.